Hello, this is Roopa Prasad, Department of Assistant Professor, Department of Computer Applications, MITS College. So today we are going to discuss about a protocol that we call it as IPSec, which is a network layer security protocol. So these are the contents. So first we are going to discuss about the introduction, that is what is IPsec that we are going to discuss. Then we come to the modes of IPsec. That is, this IPsec operates in different modes. That modes we are going to discuss. After that we are going to compare the different modes. Actually we have the two modes, and we show the comparison of two modes. Then we go for the IPsec protocol. That is, this IPsec is not a single protocol. In this, we have two different types of protocols are there for providing different types of services. One we call it as authentication header protocol. Simply we can call it as a AH protocol. And next one is encapsulating security payload, that we call it as a ESP protocol. Then finally we go for the services that are provided by the IPsec. So these are the contents which we are going to discuss today. So coming to the introduction part, this IPsec, what we can call it as a IP security. Okay, so this is a protocol. So it is not a single protocol, it is a collection of protocols. Mainly it is designed by IETF, that is Internet Engineering Task Force. So for what purpose it has been designed means to provide the security for the packet at a network layer. Okay, so we already know that we have different layers are there. The one is called as the physical layer, data link layer. Above the data link layer we have a network layer. Above the network layer we have the transport layer, and finally application layer. Okay, so at the network layer the security can be provided by using this IPsec protocol. This IPsec protocol is responsible for providing security at the network level. So whatever the packet we are transferring, for this packet, we are going to provide the security with the help of this IPsec. So it is a security protocol that is provided at the network layer. So this network layer is usually called as Internet Protocol or IP layer. So what this IPsec is going to do means it is going to helps to create an authenticated and confidential packets for the IP layer. So in the IP layer, we are using the packets to transfer from one location to one source to destination. For this package, we are providing confidentiality, and at the same time we are providing authentication for the IP packets. Okay, and it also enhances the IPsec protocol, also enhances the security of the client server applications such as the electronic mail and electronic mail. Okay, so different application, for different applications also, not only for the packets, it also provides different applications. For different applications also, it is providing the security. Okay, so these applications may have their own security protocols. Instead of that also, it is providing security. So what we are saying is, this IPsec is a security protocol which is used to provide security for a packet at the network level, and it also enhances security of clients. We have already said that it also provides security for the client server programs. And for example, we can consider HTTP. So this HTTP is a hypertext transfer protocol, which is a client server program that uses to provide the access to the web pages. So for these type of services also, it is going to provide security. It is going to provide the security. Okay, so actually this will be provided security at the transport layer. Instead of that also, it provides a security. It additionally adds a security for this HTTP protocol, and it also provides security for node-to-node communication programs such as routing protocols. For routing protocols also, this IPsec is going to provide the security. So we have already said these are the layers. So these are the 5 layers. That is our internet model. That is that what we call it as a TCP/IP model. So below is a physical layer. Above the physical layer, we have the data link layer. Above this data link layer, we have the network layer. Above the network layer, we have transport layer, and above this, we have the application layer. So this IPsec protocol is designed to provide security at the network layer. In a similar manner, at the transport layer, we are going to use another protocol that we call it as a SSL, that we will discuss later. So at the network layer, security can be provided by using a protocol called as a IPsec. What we call it as a Internet Protocol Security. That is the name of the protocol. And this IPsec protocol is going to operate in different modes, as we have said. So what are those modes? Means there are two modes. One we call it as a transport mode, or we can call another one is called as a tunnel mode. So this IPsec is going to operate in transport mode, or it can operate in the tunnel mode. So we will see what happens in transport mode. So in transport mode, what the IPsec is going to do means the IPsec protects the data that is received from the transport layer to the network layer. So it provides a network layer payload. Okay, the payload to be encapsulated in the network layer. See this one. This is a IP in transport layer. From the transport layer, the data will be transferred to the network layer. Where in the network layer, we are going to add the network layer header. Okay, so in the transport mode, what happens? The IPsec is providing security for the transport layer payload. Okay, it is not considering the network layer header. It provides the transport layer data only. That it is providing the security for the data only. Whatever is encapsulated, whatever is received from the transport layer, to that data only it is going to provide the security. So here it is going to the IPsec layer, that is the security provided by the IPsec. Here it is going to add the IPsec header, and also going to add the IPsec trailer. Okay, that what we call it as a transport layer. Okay, and another mode, what we call it as a tunnel mode. Or what happens in this tunnel mode means that this IPsec protects the entire IP packet. Okay, including the header also, it is providing the security. So from the transport layer, the data will be received by the network layer. In the network layer is going to add its own header. After adding the header only, the IPsec is going to provide the security. That means to the total packet is going to provide the security. After giving the security, it is going to add the new header. So this IP header will be added as a new header, that we call it as a tunnel mode. That is the difference between the transport mode as well as the tunnel mode. So in transport mode, it provides the security for the payload only, but whereas in the tunnel mode, IPsec provides the security for the entire IP packet, So IPsec can operate in two different modes. One we call it as a transport mode, and one we call it as a tunnel mode. Here we can find the differences. We can clearly see the differences. So this is called as a transport mode, and this is called as a tunnel mode. So we can see from the application layer, the data will be transferred to the transport layer. From the transport layer to the network layer. Before it comes to the network layer, the security is provided. Okay, that means what? The net security is provided for the data only. Okay, but here what happens? From the application layer, the data will be given to the transport layer. From the transport layer, the data will be transferred to the network layer. After that, the security will be provided. That means the security is provided for the entire packet in the tunnel mode. That is the difference between the transport mode as well as the tunnel mode. Okay, so these are the comparison, how we are going to compare the two modes. Okay, so it can operate in the transport mode, or it can operate in the tunnel mode. Okay, then we come for the security protocols. As we have already said, this IPsec is not a single protocol. It is having two protocols. One we call it as a authentication header protocol. Simply we can call it as a AH protocol. And second one is called as a encapsulating security payload protocol. Simply we can call it as a ESP protocol. So IPsec is a combination of two protocols. One is AH and second one is ESP. So these protocols are used to provide the authentication and also encryption. Okay, authentication and on-or, that we will discuss later. So authentication and encryption can be provided, or authentication or encryption can be provided at the network layer. That is a network level. For the packets at network layer, it is going to provide the security. So IPsec is having the two protocols. One we call it as authentication header protocol, and second one is called as a encapsulating security payload protocol. Simply we can call it as a ESP protocol. So first we talk about authentication protocol, authentication header protocol, that is AH. So this authentication header protocol is mainly designed to authenticate the source host. Okay, for the authentication purpose, we are going to use the authentication header, and it also ensures the integrity of the packet. So, what do you mean by integrity? Integrity means there should be no modification while the data is transferring from the source to destination. It has to ensure this authentication header ensures that the payload has an integrity. It also ensures the integrity of the payload. Okay, and for this integrity, for this authentication as well as the integrity, the protocol is going to use a hash function. The protocol is going to use the hash function and also a symmetric key to create a message digest. So, hash function and symmetric key to create a message digest, and the digest is inserted in the authentication header. Like that only we are going to ensure the authentication. We are ensuring the integrity. So then the AH is then placed in the appropriate location based on the mode. Okay, based on the mode, whether it is a transport mode or tutor mode, based on the mode, the authentication header will be placed. When we see the packet, then we're going to understand. And um, so when an IP packet carries an authentication header, so when IP datagram, that is IP packet, is going to carry the authentication header, then the value of the protocol field. As you are aware that in the network layer, that is in the IP packet header, there is a field called as a protocol field. There is a field called as a protocol field. In the protocol field, it specifies what the packet is carrying. So, if the packet is carrying the authentication header, the value will be 51. Okay, if the IP packet protocol field considers a value of 51, then what it means, the packet is carrying the authentication header. Okay, so whatever the IP header field IP header protocol field is having the value, that will be transferred to the next header field which is available in the authentication header. Okay, so see this one. This is a packet format. So when we see this one, you can able to understand. So depending on the mode, whether it is transport mode or whether it is a tunnel mode. Suppose think that it is a tunnel mode. So security will be provided for the entire packet. Okay, after providing security, that message digest will be included in the authentication header. One more header will be added, one more field will be added, that we call it as a authentication header. This is the packet and this is the IP header and this is part that we will discuss later. So this is an authentication header. This is an authentication header. Here we are going to place the authentication digest data, that is called as a digest. What we call it as a digest. So see here, an authentication header is added to the payload. To this payload, the authentication header will be added. The data is coming from the transport layer. Here we are going to provide the security. How we are going to provide the security means we are going to give this data to the hash function so that it provides the digest, and that digest is included in the authentication header. That is a procedure. So an authentication header is added to the payload and padding may be added to make the total length even for a particular hashing algorithm. So this padding, why we are going for padding means what? Adding extra bits, in order to make the length, equal. That is for example, hash function. We take SHA algorithm. I think you are aware. So in the SHA algorithm, what is the main rule? The message has to be divided into 1024 bit blocks. Okay, it has to be divided into 1024 bit blocks. That means the message should be the multiple of 1024 bit blocks, 1024 bits. So in order to make that message, that length, in order to make it possible, in order to divide into equal blocks, so we are performing this part so that it can be used by any hashing algorithm, particular hashing algorithm, based on the hashing algorithm. Suppose if we are using SHA for this in order to ensure the integrity as well as authentication, if you are using the SHA algorithm, then there is a rule that it should be the multiple of 1024 bits. So in order to make it possible, we are going to use the padding. So the hashing is based on the total packet. Total packet will be given to the hash function. Okay. However, those fields in the IP header that do not change during the transmission are included in the calculation of the message address. This is the IP header. So this IP header is having some fields. Okay. Those fields which are not going to be transferred during the transmission, that only consider for the hashing purpose. That only consider for the hashing purpose. Say for example, in the IP header you have a field called as a live mm, router time to leave, time to leave. That field will change continuously whenever it reaches whenever the packet reaches one router, the count will be decremented. Okay, so that field is not taken for consideration for the hashing function, so those fields, those header fields that do not change during the transmission are included in the calculation of the message digest. So what we call it as authentication data. So the authentication data is included in the authentication header. After calculating the authentication data, that is a message digest, that will be placed here. So after placing this one, in the IP header, there is a field called as a protocol field. That field will be changed to 51. What is meant, that is this packet has been protected by IP AH, that is a AH authentication header, and authentication data is included in the packet. That will be intimated by using the protocol, by making the protocol field to 51. Clear? That is called as authentication header. Next, we are going to discuss about the fields of the authentication header. There are the fields in the authentication header that we will going to discuss. So the first field is called as next header, which is of 8 bits, So what this next header contains means, in the IP header there is a field called as a protocol field. Okay, in that field, whatever the value is there, whatever the data is there, that will be transferred to the IP next header, that is AH next header. Here we are going to give the value as 51, but that value will be transferred here in the field called as a next header. Then it also contains a payload length. Which is the length of the authentication header only. Then these 16 bits are reserved. Then we are having a field called as a security parameter index. This is used for the connection. This is the number given for, this is the index, the parameter index that is given for the connection. And we have a sequence number. Sequence number is mostly used in order to avoid the replay attack. And we are including the authentication data, which is of variable length. These are the fields for the authentication header protocol. And coming to this encapsulating security payload protocol, this is one of the protocol of the IPSec. So it provides host authentication, integrity, and privacy. That is, authentication header provides the authentication as well as the integrity, but privacy is not provided by the authentication header protocol. So privacy can be provided by using this encapsulating security payload. For that purpose, we are having two protocols. One is called as a AH, that is authentication header, and second one is called as a encapsulating security protocol. So authentication header provides authentication as well as the integrity, whereas this ESP provides authentication, integrity as well as the privacy. Okay, so in the authentication header, we have only header is there, but this ESP protocol adds both header as well as a trailer. Okay, so authentication data is placed at the end of the packet. When an IP datagram carries ESP header and trailer, the value on the protocol field will be 50. Okay, if the IP packet is carrying AH protocol, the value will be 51. If the packet is protected by ESP, the value will be 50. That is the difference. So AH protocol gives authentication as well as integrity, but not privacy. In order to include privacy, we are going for another protocol that is called as the ESP protocol. In the ESP, we are having both header and trailer. So in the trailer part, we are going to have the authentication data. And what is the field contains? Protocol field contains the value 50. And we see the procedure. So first, the ESP trailer is added to the payload. Okay, to the payload, we are going to add the ESP trailer. The payload and the trailer are encrypted. Now, coming for the confidential, for the privacy, it has to be encrypted. It has to perform the encryption. After encrypting the payload and the trailer, we are going to add the ESP header. Okay, so this ESP header, payload, and trailer are used to create the authentication data. So all these three will be given to the hash algorithm in order to produce authentication data. Then the authentication data is added to the ESP trailer. Okay, the IP header is added after changing the protocol value to 50. That is a procedure. So what this ESP is going to do means, in this ESP protocol we have two. That is, a trailer is having, and we have the trailer header is added to the front of the packet and trailer is added to the end of the packet. So here we are going to add trailer to the payload. First we are going to add the trailer to the payload, that is a packet. Then that payload and trailer both are encrypted. Then header will be added. Then 3 are given for the hash algorithm in order to generate the authentication data. Then authentication data is added to the ESP trailer. Then in the IP header, the protocol field value changes to 50. So this is the packet. This is the ESP packet. So here, this whole is the IP packet. So first what you are going to do is you are going to add the ESP trailer and payload. Both are encrypted. After encryption, we are going to add the ESP header also. After adding the header, this will be given to the hash function in order to generate the authentication data. Then this authentication data will be appended to the end of the trailer. Okay, that is a procedure. So what this header contains? Header contains the security parameter index as well as the sequence number, whereas this trailer contains the padding bits and pad length and also the next head. So these are the fields of the ESP. Then we come for the services that are provided by the IPSec. So this IPSec, we are having two protocols. One is called as the AH protocol and another one is called as ESP. And these are the services that are provided by the IPSec. One we call it as the access control. It provides the message integrity. It provides the entity authentication. It provides the confidentiality. It provides the replay attack protection. Okay, it gives a protection from the replay attack. So these are the services. One we call it as the access control, and then next is the message integrity. So what do you mean by access control? Means IPSec provides access control indirectly. Okay, how the access control can be provided means by using the security association database. So when a packet arrives at the destination, there is no security association already established for the packet, then the packet will be discarded. So access control. Access control means who has to access the data, who has to access the data. That is provided by using the security association database. So what happens when the packet receives at the destination, when the packet is received by the destination, so what the destination is going to do means the destination is going to check for the security association. So in the packet there is a security parameter index is there. So it will check the index. So that index will be checked in the database. If it is not available, then the packet is discarded. This means what? Now, thereby we are providing the access control. Then coming to the message integrity. So message integrity, how the messages integrity is provided means in message integrity is having in both protocols. AH protocols also provides message integrity as well as ESP also provides a message integrity. So what is meant by message integrity? Integrity means the data should not be modified or changed. So whatever the data has been created and sent by the sender, that has to be received. So the receiver checks whether the data that has sent by the sender is that data only that he has sent. So for that one purpose only we are calculating the message dices. So this integrity is provided in both the AH protocol as well as the ESP protocol. Then authentication. One of the service provided by the IPsec is entity authentication. That means what? Authenticating the source, authenticating the sender, So authentication can be done by this is available both in both protocols, that is protocol as well as the ESP protocol. By using the keyed hash dices, we are going to provide the authentication. We are going to provide the authentication in both protocols, that is in protocol also and ESP protocol also. Authentication can be provided. And how the confidentiality is provided means confidentiality is provided by encryption. Confidentiality is provided by the encryption. So this confidentiality in protocol, we are not providing the confidentiality. Why? Because we are not going to use any encryption algorithm in the protocol, but in ESP we are going to provide the confidential. We are going to provide the confidential. Suppose if a packet needs confidentiality, if a packet needs authentication and integrity, then they can go for the protocol. If the packet is need of the in confidentiality also, then we have to use a ESP instead of That is the only criteria we have to check. Okay. And another service that is provided by IPSec is replay attack protection. It gives protection against the replay attack. Replay attack means what? Once the sender has sent the data, that data is again resent. That data will be taken by the third party and that data will be resent. Okay. So in order to avoid this protocol, that is IPSec protocol, both in IPSec we have the two protocols, right? In the two protocols we are going to provide this service, that is a replay attack protection service. So what happens? It is going to use a sequence number. It is going to use the sequence number whenever the security association is established. Whenever the security association is established between the two parties, the IPSec header is going to generate one sequence number. Okay, so the number starts from 0 and increases until it reaches 2 to the power of 32 minus 1. If it reaches the maximum, it is set to 0. So these are the contents, and these are prepared by using these references. And if you have any queries, you can make a contact. Thank you.